Hello, and welcome to DevDay. I'm Boaz Ziniman, Technical Evangelist at AWS, and today we are going to talk about 5G mobile networks. What do you, as a developer, should know about them? How to deliver applications that require ultra-low latency to users and devices on 5G mobile networks. And why should you care? Our agenda for today will include some basic introduction to 5G networks. We are going to talk about several use cases that we see in this industry that our clients are already using. We are going to talk about AWS wavelength, which is our solution to deploy your applications for 5G networks. We are going to talk about the developer experience that is very important for you to know how to exactly do that and see the differences that are not huge between deploying regular applications to AWS regions and how to deploy them to AWS wavelength. And we're going to show a demo of an application, in this case an IoT application, that takes data from users and store it on AWS while sending the data to AWS wavelength and creating this 5G application. So let's start to talk about 5G. And first thing first, let's dive into the technology of 5G that I'm sure many of you heard of, but what it means exactly and how can you develop new use cases that would not have been possible to deliver with LTE cellular technology, like maybe some of you know as 4G or maybe even 3G. This is what 5G is about. So why is it time for the next G or the next generation of mobile technology? If you look at the progression, we have had a generation change every decade or so, starting with 1G, which was analog, followed by 2G, which was transformation to digital. 3G was built to start data in addition to voice. That was a huge change. And 4G was about higher bandwidth to support broadband data, video, and etc. And I think if you use cellular networks, you know exactly what I'm talking about. So what does 5G intended to do? 5G is different than previous generation in the sense that it's not only about more faster data pipes. Sure, 5G is faster, as you can see in this video, from my new 5G supported device. You can see it's faster. Obviously, it's not only the speed that max out at about more than 300 megabits per second versus about 20 on 4G. Take a look at the ping times and jitter. And you can see a huge difference there as well. And this is, of course, very important. I took this video just a week ago, one of them on a 4G network, on a local 4G network, and one of them on a 5G network. And you can obviously see the differences between the two networks, not only in speed, but in jitter, in latency, ping times, and so on. Unlike previous generations of mobile networks, which were just about increasing bandwidth, 5G is about a lot more. 5G networks are being built to serve new use cases. As such, the goal of these networks is to achieve, first of all, a very high bandwidth, as you saw in the video, ultra-low latency, and very large device scale. How large, you probably ask yourself? So if you look at 5G characteristics, you can see that you can get, and you saw it on my video, you can get a lot more than 100 megabit of data rates when using this network with much higher peaks, with super low latency in a single-digit millisecond, and it can support up to 1 million devices for every 1 square kilometer. And this is a lot, and this is very different from previous networks. How does 5G networks deliver these benefits? So it achieves it through advanced wireless technologies. First of all, upper bands of the spectrum are being used to deliver high bandwidth. Wider spectral band will allow much higher bandwidth, and this is one part of the system. The new antenna technology is being developed to support more multiple devices at these high bandwidths, and this is another part of the system. And later, network functions will enable the network to be virtualized, providing flexibility of deploying components in various parts of the network and dynamically adjusting the network to what each component needs. But there is more, and this is very, very important. The other element in 5G networks is about moving network components and applications closer to the users, to the edge of the 5G network. Here is a typical end-to-end network. So you probably saw that before and you might be using it. Users are connected over cell towers or fixed lines, it can be home or enterprise lines, to a proprietary CSP. This is communication service provider. We're going to use this term a lot during this talk. And this network transit or peering points which then connect to the public internet, which in turn connect to AWS regions if you're using AWS. The latency of such a connection can be very long. It actually depends on where the users are and where the region are and specific paths traverse to reach the application in the region. And typically, it can go in the order of hundreds of milliseconds if you look across the population of subscribers in different locations. So this is more or less the average you're going to get, hundreds of milliseconds. However, with compute instances running at the site embedded in the CSP network is very close to users, both geographically, but more important, from a network distance. The latency can be of the order of tens of milliseconds, getting into low single digits, depending on the specific site and network connectivity. So this will allow you to run your applications much faster. Which applications exactly? Let's talk about some use cases. There are many use cases where 5G can help, such as healthcare, for example, where AI and machine learning-driven video analytics and image matching solutions help doctors speed up diagnosis of observed conditions, such as recognizing polyps during colonoscopias. The video streams from medical devices are processed in the 5G network, and the response is returned to the medical device for the surgeon to use. Connected cars is another example that enable capabilities such as improved road safety. Low latency access computer infrastructure is needed to run data processing and analytics to monitor data from sensors for secured connectivity, in-car telemetry, and safety warnings. 5G also provides the ultra-low latency needed to live stream high-resolution video and high-fidelity audio, as well as to embed interactive experience into live video streams. Additionally, video analytics provide the ability to generate real-time statistics that can enhance live events experience, and it can be in concerts, in gaming, and many other examples. And it's not only the speed of the network. If we take, for example, a use cases with high uplink data, like in this example when you have your 24/7 cameras uploading data to the cloud, that require processing this data as multiple video streams. With processing it early in the network path, reduces the network bandwidth used that can lead to significant cost saving in both bandwidth and storage. So if you have these video cameras sending data to the cloud 24/7, instead of storing everything on AWS and processing it there, you basically move the processing earlier in the process and use the CSP networks to the computing on the CSP networks to do the pre-processing and then upload only the data that you need. You might use machine learning models to identify things or identify people and send only the important information to the cloud, once again, saving a lot of on bandwidth and data storage. So these are the use cases, and there are many, many others. And now let's talk about some of the technologies that allow you to move your processing to the edge closer to your users and focus on AWS wavelength. So AWS has dozens of regions that enable developers to build applications that provide low latency globally and comprehensive set of solutions for building edge applications. Outposts, local zones, and wavelength all bring AWS services to more places with the same experience and benefit that developers are used to. Wavelength, which is our focus in this session, is unique in that it is designed to enable developers to build ultra-low latency applications by extending AWS infrastructure services, APIs, and tools into 5G networks. Developers can take existing applications and extend them to wavelength zones, or build new applications using AWS services like EC2 or containers offering such as EKS. Wavelength is AWS infrastructure that is located and installed in a physical site that is part of the communication service provider network. A CSP network, as we mentioned earlier, has physical locations such as a cell towers that connected with traffic aggregation points at metro levels. Wavelength zones are installed at these metro aggregation sites. The 5G accesses network is directly connected to the wavelength zone through a constructed called carrier gateway, allowing mobile devices to access the instances in wavelength zone without going to the internet. And this is changing dramatically the way your clients are going to connect to your application. Wavelength zones are managed and monitored by AWS and connected over a high bandwidth link to the AWS region. Applications in wavelength zones can use the core services such as EC2, EBS, ECS, and EKS, so you already know these services and you can use them inside wavelength. Applications can also connect seamlessly to other services such as DynamoDB databases, S3 in the AWS region. We're going to show you this as part of our demo. We're going to use AWS IoT and DynamoDB. And you can deploy portions of your cloud-based applications requiring ultra-low millisecond latency to wavelength, and then connect seamlessly to the rest of your application and services running in a regular AWS region, same as you've been doing before. Wavelength zones deliver a consistent developer experience across multiple 5G networks around the world, allowing you to build ultra-low latency applications using the same familiar AWS services, APIs, tools, and functionality you are already used today. And you don't need to reinvent the wheel each time you need to onboard a new network that is became available on Wavelength. Wavelength is available in several locations in North America with our partnership with Verizon, in Japan with KDDI, and South Korea with SK Telecom. We already announced plans to launch in Europe with additional partners, and make sure you check our website to see what is next and what is coming in terms of new zones that you might be needed for your applications. As mentioned before, latency of applications deployed to AWS regions depend on where the users are, where the regions are, and the specific path traversed to reach the applications in the region. With AWS Wavelength and compute instances running at a site embedded in the mobile network, this network distance is reduced, and it's actually reduced dramatically. Since the network path is shorter and quality of service is highly controlled in mobile networks, the latency in this case is really predictable and has less jitter, which is important for applications such as gaming and other that require tight synchronization across users. AWS wavelength zones are connected to a parent AWS region using a high-speed service link. They are actually part of this region. So applications running in wavelength zone can easily access resources from the rest of your VPC and endpoint that are running in the region over a managed and secured link. AWS recommends that you architect the edge applications in a hub and spoke model. We're going to talk about it in a second. With the regions as a hub, providing the most scalable, resilient, and cost-effective options for components, allowing you to run the components that are less latency sensitive or that needs to be, for example, of a persistent state, such as databases, training machine learning models, and backend worker processes. You then run your spoke applications components that are latency sensitive in the wavelength zone. In addition to wavelength zones, edge locations can include regions, local zones, and outposts, as mentioned before, and you can mix and match according to your exact needs, and there are many different options for you to build your applications. Speaking about building your application, let's discuss a bit the developer experience. How can you as a developer take advantage of wavelength zones? And let's dive into your developer experience and how can you move your applications closer to your customers. With wavelength, you can build applications with familiar AWS services. You can use EC2 instances and Amazon Elastic Block Storage for your storage. You can use networking. It's the same Amazon Virtual Private Cloud, Amazon VPC that you've been using for a very long time, and of course our container services, as I mentioned before. In addition to that, you can use all the AWS APIs and tools that you're familiar with in the region, such as EC2 auto-scaling groups, or CloudFormation to deploy your application, and of course CloudWatch and CloudTrade to track every API call that is being done to your infrastructure, and many, many more. And this is part of the ease of use of Wavelength, that all the components you're using there are very, very familiar, and most of them are something that you already used before. So how do you start? First, you need to be into Wavelength to use it. So if you have a use case to use Wavelength, please go to our website and fill in the form to access Wavelength. Then you're starting with just the same AWS region like you used to do for every other application you build. And this region has to have Wavelength zones connected to it. Not all of them are supporting Wavelength, so make sure you're using the right region. Then you start to create your VPC, and it's exactly the same VPC that you've been building before for a specific application. And inside this VPC, you are going to start deploying networks, availability zones, and in this case, maybe 2, maybe more, depending on the region you're running. Inside those availability zones, you're going to start deploying your networks. So some of them might be private subnets, other might be public subnets. You are going to define the IP range and all the security settings and connectivity between the different subnets. Of course, creating routing tables and defining who can access which instances in which subnet based on availability zones and so on. Then the next stage is basically taking the same VPC and extending it into a wavelength zone. So nothing new here. You're just adding inside an existing VPC additional subnets. In this case, they are going to be placed inside the wavelength zone. It can be 1, it can be more than that. And then you are able to place instances inside those subnets or deploy your ECS or EKS applications into those specific subnets. So in this case, I have 2 subnets with 2 instances. And then I'm starting to create my routing tables and routing rules for those instances, adding security groups. Once again, nothing new here. I can use network ACLs as well and add additional capabilities to the instances and the network inside my wavelength zone, same as inside the region. Then I'm basically, with the right routing tables, I can allow access of my instances inside wavelength zone to all my instances inside my other availability zones, which are inside the region, start sending data, access services, and so on. And there are many other things you can create inside a wavelength. For example, I can add the internet gateway for my network to allow access to the internet. I can access services inside my region. I already mentioned S3 and DynamoDB, but other services like Lambda or SNS, SQS, in our case of the demo, we are going to use AWS IoT. And of course, you can add additional rules for your network. And what you can add in addition is basically add the carrier gateway that in this case will connect you to the specific carrier network and allow devices on this network to connect directly to your wavelength zone without going to the public internet. You are going to get an IP inside the network and you're going to use this IP to expose your services. So then your applications can actually go directly inside your network. Remember that wavelength zones are not available in the public internet unless you define it. So all the access to those instances should be through the carrier provided network. And this will allow your customers to get these low latencies when using those mobile devices. It can be mobile devices, it can be smart devices, connected cars, and so on. One example of deploying a gaming application inside wavelength zone. So as I said before, it's basically one VPC extended across the region and the wavelength zone, and then I'm deploying my application, the portion of the application that sits on the region, my backend, if you like to call it that way, in this case the player state services, and then I deploy my game server into VPC, and it will connect, in this case Lambda, with my player state service and get all the data on the player, and then I can have a service discovery in addition that will store all the locations of my different applications. A new device will connect to this service discovery and will get the address of the carrier gateway to connect directly to my gaming server. In this case, I'll put all the things that doesn't need to have, they are non-latency sensitive inside my VPC, and all the latency sensitive near real-time computing and some replica of selective regional data inside my wavelength zone, and that will allow me this super fast experience of gaming that people are looking at for today on mobile devices and other type of devices. Our demo will do something similar. Our demo will basically create an application to collect IoT data from devices on a 5G network. I already created the left part, the local part inside the AWS region, VPC with all the availability zones and the subnets inside it with the routing tables connecting the wavelength zone. And we are going to build the wavelength zone and the application. In this case, we're going to install an EC2 server with an MQTT client, MQTT agent that will allow us to receive and send data using MQTT from the devices and to the region to store it and process it. In this case, we are going to use AWS IoT Core, and we're going to access this service directly from the wavelength zone. So let's move to the demo. So as I already mentioned, I already have my starting point. I created a VPC inside my region. I'm using North Virginia in this case. So this is my VPC, just a regular VPC, nothing special about it. I created inside the VPC a subnet. I created only one, but obviously you can create it more than that. In addition, I created all the route tables, internet gateways, some definitions for security groups, so you can actually access this subnet and you can place instances there. I would like to check if I'm actually allowed to go and use wavelength zones. So I'm going to use the CLI. I'm going to use the CLI a lot today, and I'm going to do EC2 describe availability zones and look for availability zones in the region I'm working in. As you can see, I got 6 availability zones, regular availability zones, and another 6 for wavelength zones. Now let's start setting up my subnet in the wavelength zone. So first step, I'm going to create a subnet inside my wavelength zone. So I'm just using an AWS EC2 create subnet command using the same VPC ID that I already created, defining in this case the availability zone to be one of the wavelength zones. If I switch back to my subnets in the console, you can see that now I have 2 subnets. The first one is the one that I created for the region, and the second one is the subnet inside the wavelength zone. If I'm going to check it, you're going to see that the availability zone for this specific subnet is inside the wavelength zone in Boston. Next is my network setup. So first stage for this, let me clear this up so it will be easier to read. I'm going to create the carrier gateway that will connect this wavelength zone into the carrier network. This is a very important part, especially for wavelength, and this will create the right routes. I have a few more commands that I need to run at this stage to create custom route table and default routes and so on, just to finalize the network topology of this specific availability zone. I'm going to run it really, really fast. And then we're going to talk a bit about security for the MQTT. Now I would like to create security group for my subnet, just to use it with my future MQTT application. So I'm going to create a security group, just a general one. inside this VPC. And then I'm going to allow two services. One is MQTT on port 1883. This is the default port for MQTT. This is going to be open for everybody. The second rule is going to be to allow SSH, so I will be able to install software on this specific security group. For SSH, I'm going to limit it only to my IP address, just to make sure that nobody else can access this machine. Describe the security group, just to see that everything is done. So in this stage, I would like to create some IAM roles and policies to attach to my EC2 instance. Obviously, this is something that I would like to automate later on, so I'm starting with creating a role, then a few more settings like attach role policy, and then I'm going to create an IAM instance profile to attach to my instance and add the role to instance profile, and then are basically ready to start and launching my first instance. So now to the fun part. Let's launch our EC2 instance inside the wavelength zone. Just a regular EC2 run instance command. I'm using all the settings I created before. So let's run this one. Okay, and if everything went well, I can go now to my console and actually see this instance spinning up. Let's check it out. So this is my instance. As you can see, it's already running. That was pretty fast. It is a T3 medium instance. It got the IP. It's in the right security group. If I'll go to networking, you'll see that it's actually running in availability zone inside wavelength. And now I can start working with this instance. Next, I would like to associate this new instance with an IP coming from the carrier. So I'm just going to get the internal IP of the instance, just to put it as a parameter. And then I'm going to run EC2 allocate address and allocate an address from the carrier network. I'm going to associate this address with my EC2 instance. Now, since I'm not on the carrier network, I can't connect to this instance using SSH from my machine. I have to be on the carrier network. So I created another instance in the regular region, one of the availability zones. And then from this one, I can actually SSH into my wavelength machine. So let's connect to this machine using the internal IP. And as you can see, I'm now connected to the wavelength machine. So to save some time, I skipped the installation of the MQTT broker on the wavelength machine. And I created a rule inside AWS IoT that will store all the messages coming to this rule into a DynamoDB table. Now I can actually go and start publishing messages to my Mosquito topic. And each time I publish a message, and I'm going to try to publish several messages that will look slightly different in terms of the device ID. It's as if somebody connects to my network and publish an MQTT message to my broker, and this one will go to the DynamoDB table and will be stored there. So I'm actually accessing from my wavelength zone a service inside AWS. And as you saw, this is exactly the same as creating any service in any other regions and availability zones. So pretty simple, more or less the same as deploying your application to any AWS region. And this is how you bring your application closer to your customers using 5G networks. And it's not only IoT. Our demo was focusing on IoT devices using the carrier network. But you can use wavelength zone to connect mobile phones or modem, connected cars, and any devices that can enjoy the short latency and, of course, security. Because in all of these cases, the data does not leave the carrier network and does not use public internet. My demo was using EC2 instances inside my wavelength zone subnet to receive data from my IoT clients out there. But as I mentioned earlier, this is not the only option. So in addition to EC2 instances that can run on your subnet, you can deploy your application and extend your regular AWS region using containers. You can deploy your app in the same way you deploy it today using containers, using both ECS and EKS, and if you prefer Kubernetes, of course. And that will allow you to have an end-to-end solution. Starts with your development environment using containers, to your production on AWS serving regular customers, to your wavelength zone serving your mobile customers. All with the same code base and orchestration. Just create the initial network topology and you are good to go, and add your new subnet and just deploy it as an additional target. Let me share with you some more examples of what can be done today using 5G. So first one I would like to share is virtual reality implementations, and specifically a topic called remote engineering. So in this specific topic, an engineer on site can use virtual reality to fix a machine or something that is broken that he maybe never saw before. And by adding a layer of virtual reality on top of what he sees using some VR devices like Gear VR or Oculus and some others, you can actually transmit a layer to this engineer using remote engineering and add this ability to see things virtually on top of what is available for him. So this type of solutions are using all kind of smart lenses, VR lenses that is being wear by the engineer. And usually you need some GPU processing power locally on those devices, so you can actually take and match the two layers, the physical layer and the virtual layer. When we're using regular internet local ISPs, it went to AWS, and there on a pretty powerful machine, in this case a G4 machine, we were creating this virtual layer on top of it. Today, when you can use 5G for those, you can move a lot of this processing to the wavelength zone, because the latency to this wavelength zone is minimal. And then you can basically save on providing powerful computing on the customer level and move most of it to the cloud. Then you have the service link, of course, that will allow you to access AWS Cloud for additional services, to get more data, maybe to get the manual or all the specifications of a specific machine, and so on and so forth. Another great example is data analytics at the edge. So in many cases, we are using the cloud for data analytics because it saves us a lot of money, saves us a lot of resources. But what about events like sporting events, when you need to process a lot of data in near to real time? If it's a football match or Formula One, this is another great example. So you want to track players, you want to track speed, you want to calculate all kind of things like direction of the ball and the chances to score a goal. And we see all kind of platforms generating a lot of data from a lot of different devices. So it can be sensors on players, it can be cameras in stadiums and venues, and all this data is being streamed and processed sometimes locally, and this is a very big challenge when you need to move this infrastructure from place to place. When you do it locally, sometimes you use 4G network, sometimes you use a regular wired network. At the end of the day, it will go through the public internet to your AWS cloud. We'll do all the analytics and processing, and then you can consume these statistics with some kind of external service, show it to your viewers during the TV broadcast or something similar. When moving to 5G, you can move a lot of this deep analytics image processing to the cloud, to the actual wavelength zone. And because of small latency and performance, your customers can really enjoy this near real-time experience, and then of course connect the streaming, statistics streaming directly to your wavelength zones and save a lot of the infrastructure that you're usually running when creating something like this with regular connections. Another example is 5G or IP-based video distribution, and in this case we're talking about distributing content coming from different sources. So I actually have content creation studios that are out at the field. They will create the video streams. Sometimes I'm going to do local transcoding to save some bandwidth. Then I'm going to send this data to my, using Direct Connect usually, or IP network, to AWS Cloud, where all my media processing elemental tools, this is the media services from AWS, are going to take care of creating
the content for distribution. I'm going to use CDN, CloudFront, to distribute it to my distribution network. It can be satellites, it can be anything else. With 5G, I can take this data that's being produced on AWS Cloud and directly push it into wavelength, and then allow customers to connect using IP 5G distribution to my stream directly, and of course provide a much better experience to my customers. Last example, caching from the edge. So caching content in general, this is something we do a lot, and we do it for many reasons. Of course, we want to get low latency, especially when we're talking about video, when we're talking about broadcast, live events is super important to have low latency. And we would like to provide today very high quality. So if full HD, 180p was the standard several years ago, today 4K and even 8K are becoming a standard. And of course, each one of them requires more bandwidth and more processing power. And we see it a lot with media streams. And in our case, the AWS region is actually the one that is generating the content. So all the information is going to be streamed into an AWS region, and then we're going to have the streaming software there. And using the AWS, the Amazon backbone, we are going to distribute this content using CDNs, CloudFronts, to our customers. If we're adding to this architecture our AWS wavelength zones, now we can distribute the same content, the exact same content from the exact same resource to my mobile customers using the wavelength zones and directly to the carrier network using 5G. This will allow me to have low bit rate, lower quality streams using the regular network, using CDNs, and much higher streams for my 5G users that consuming this using wavelength zone. To wrap up, some takeaways. So first of all, 5G is not only about speed. When you are deploying and creating new applications and new use cases for 5G, rethink your application architecture and make sure you're using the right tools to bring it to your customers. We spoke about several techniques like hub and spoke, and this is something you should take into account when designing your new application. And AWS Wavelength is an extension of your current VPC, and you just need to think about it as something like that to bring your application closer to your customers and use all these new characteristics of this new network. I added here some resources that you should follow if you want to opt into Wavelength, and some blog posts from Verizon 5G Edge blog that are writing a lot about creating applications for 5G, so feel free to use them, and feel free to contact me and ask questions. Thank you very much for watching this session, and see you next time.